We're finishing up our do now in 3, 2, 1. Pencils down, eyes up. Waiting on 100%. Good. All right, so now we're going to put our do now slip on the side of the table. I'll be coming around picking it up, and then I'll give it to you tomorrow. So today we are learning how to identify like terms and to combine like terms together. And you'll be showing me this by mastering the exit slip at 80% or at the level of 80% accuracy or higher. And so why are we doing this? Why are we learning this? We're learning how to identify like terms and grouping them together because these are essential skills needed in order to solve more complex equations in the future. So first we're going to be learning about identifying like terms. To identify like terms, the like terms have to have the same exact variable and the same exact power. This is really important. So I want you all to read this out loud with me in a teacher voice as I guide my fingers through it. All right, ready? In 3, 2, 1.
Like terms have the same exact variable and power.
Good. All right. So what do I mean by this? Here I have an example of 4x and 3. And I'm trying to figure out whether these are like terms or not like terms. And in order to figure this out, I'm going to follow the definition that I have read before me. So they have to have the same variable and power. I see that 4x and 3 does not share the same variable. 4x and 3. 4x has an x, but 3 doesn't. So because of this, they are not like terms. And the reason is because they don't have the same variable. So now with using the other examples, we're together as a class, we're going to be figuring out whether these are like terms or not like terms. And in order to tell me whether these are like terms or not like terms, we're going to be using our fingers. I know most of you are Facebook users. So using our thumbs, we like something. Putting our thumbs up means that we like something. In order to say that it's a not like term, we're going to put our thumbs down. Okay? So 4x and 3y. Is this a like term or not a like term? We're going to put our hands up in 3, 2, 1. Hands are up. Good. I see that everyone has put their thumbs down, meaning they are not like term. And Carla, I saw you put your hand up first. So why is it not a like term?
Because they don't have the same variables.
Good. They do not share the same variable, 4x and 3y. They're both different variables. Now we're moving on to our next question, which is 4x and 3x squared. Is this a like term? Start thinking and thinking about putting your hands up in 3, 2, 1. Hands up, hands up. You have all said that yes, it is a like term. That is not correct. We're going to go back to help us out. We're going to go back to the definition. Carla, can you read this out for me, please?
Like terms have the same exact variable and power.
Okay, same variable and same power. Are these two terms, 4x and 3x squared, do they share the same variable? Core response in 3, 2, 1.
Yes.
Yes.
Core response in 3, 2, 1.
Yes.
Yes. They share the same variable, x. Do they share the same power? Core response in 3, 2, 1.
No.
No, they do not share the same power. So it is because of this that it is not a like term. They do not have the same power. Okay. So next one, 4x and 3x. Are these like terms or not like terms? Using your thumbs, ready, and 3, 2, 1. Hands up. Good. I see a consensus here. Yes, they are like terms. And why are they like terms, Adeline?
They have the same exact variable and power.
Yes, they both have the same exact variable and power. So now that we've learned the skill of identifying these like terms, we're going to be using this to learn how to combine the like terms together. So here I have written down a list of steps for you to follow when combining like terms. 1. Identify the like terms in the expression. Then you're going to be drawing shapes around the like terms with the signs. We're going to then add or subtract the like terms together. And then we're going to bring down the rest of the terms. What do I mean by this? So here I have an example of a long expression that I have been given. And I know that I can shorten this down a little to make it easier for me to read. So number 1, I'm going to identify the like terms. Here I see that 3x squared and 6x squared are like terms because I know that like terms have the same variable and power. And so does 12x and 5x and 4 and 2, negative 2. So in order for me to help me read which ones exactly are like terms, I'm going to be drawing shapes around them. So 3x squared, I'm going to be drawing a triangle. And so will its pair of like term, which is 6x squared. And making sure that I add also the sign, the addition or subtraction sign. So here I have 12x, I'm using a circle. And then it's like pair, which is 5x, circle. Then I'm going to be using, lastly, I'm going to be using a square for plus 4. And then another square for negative 2. Alright, so now I'm going to go to step 3, which is adding, subtracting like terms together. I'm going to be bringing down these like terms and making sure I use my arrows or my lines to help me read it through. So here we have 3x squared plus 6x squared. That gives me 9x squared. And now I'm going to be using my circles to bring that down as well. And 12x plus 5x gives me plus 17x. And last but not least, I'm bringing down my plus 4 and negative 2, which gives me positive 2. I'm just going to box my final answer. And this shows that I have combined like terms, and by combining like terms, I have really simplified my long expression in order to read it into a shorter expression. This is my song about identifying like terms and combining them too. Well, today we learned identifying like terms and grouping them together. We gotta confirm. For them to be like terms, they share 2 things. Keep them in your head. You'll feel like kings. Like terms share the same exact variable, the same exact variable, the same exact variable. Then they have the same exact power. Gotta keep the power. Don't be sour. To combine like terms, we gotta see the like terms. Make sure to use those shapes. Draw them out. Your numbers won't escape. Next, add, subtract our like terms together. Expressions got shorter, combined all together.